Network services and applications. Administered via homework 1 was assigned due 1 by 23rd to be completed individually. Principles of network applications, our goals, conceptual implementation, aspects of network application protocols, transport layer service models, client server paradigm, peer-to-peer paradigm. Learn about protocols by examining popular application level protocols HTTP, FTP, SMTP, /POP3/IMAP/DNS. Programming network applications, socket API. Some network apps, email, web, instant messaging, remote login, peer-to-peer file sharing, multi-user network games, streaming stored video clips, internet telephone, real-time video conference, massive parallel computing. Creating a network application, write programs that run on different end systems and communicate over a network. Example, web server software communicates with browser software. No software written for devices in network core. Network core devices that do not function at app layer. This design allows for rapid app development. Application architectures, client server, peer-to-peer, hybrid of client server and peer-to-peer. Client server architecture, server, always on host, permanent IP address, server frames for scaling. Here question arises, how do server forms still maintain a single IP address externally? Clients communicate with the server that may be intermittently connected, may have dynamic IP addresses, do not communicate directly with each other. Pure peer-to-peer architecture, no always on server, arbitrary end systems directly communicate, peers are intermittently connected and change IP address. Example, GNutella, highly scalable, why but difficult to manage. Hybrid of client server and peer-to-peer, Napster, file transfer peer-to-peer, file search centralized, PS register content at central server, PS query same central server to locate content. Instant messaging, chatting between two users is peer-to-peer, presence detection, location centralized. User register its IP address with central server when it comes online. User contacts central server to find IP addresses of buddies. Processes communicating. Processes, program running within a host. Within a same host, two processes communicate using inter-process communication that is defined by OS. Processes is different host communicate by exchanging messages. Client process, process that initiates communication. Server process, process that waits that to be contacted. Question, does it have to have a fixed port? Note, applications with peer-to-peer architectures have client processes and server processes. Sockets, process sends, receives messages to or from its socket. Socket analogous to door, sending process shows message out of order. Sending process relies on transport infrastructure on other side of door which brings message to socket at receiving process. API, 1. Choose of transport protocol. 2. Ability to fix a few parameters. Addressing processes. Identifier includes both the IP address and port numbers associated with the process on the host. Example, port number HTTP server 80 for mail server 25. For a process to receiving messages, it must have an identifier. A host has a unique 32-bit IP address. Question arises here is, does the IP address of the host on which the process runs suffice for identifying the process? Application layer protocol defines types of messages exchanged. Example, request and response messages. Syntax of message types, what fields in messages and how fields are delineated. Semantics of the fields. Example, meanings of information in fields. Rules for when and how processes send and respond to messages. Public domain protocols. It is defined in RFCs. It allows for interoperability. Example, HTTP, SMTP. Proprietary protocols. Example, Hazasa. What transport layer does an app need? Data loss. some apps, example audio, that can tolerate some loss. Other apps, example file transfer, telnet, that require 100% reliable data transfer. Timing, some apps, example internet telephony, interactive games, that require low delay that to be effective. Bandwidth, some apps, example multimedia, that require minimum amount of bandwidth that to be effective. Other apps, elastic apps, make use of whatever bandwidth they get. Transport service requirements of common apps, applications, file transfer, email, web documents, real-time audio video, stored audio video, interactive games, instant messaging. Based on the application, how the data losses, bandwidth and time sensitive that are varied is given here. Internet Transport Protocol Services, TCP service, connection oriented setup that required between client and server processes. Reliable transport between sending and receiving process. Flow control, sender won't overwhelm receiver. Congestion control, through sender when network overloaded. Does not provide timing, minimum bandwidth guarantees. UDP services, unreliable data transfer between sending and receiving process. Does not provide connection setup, reliability, flow control, congestion control, timing or bandwidth guarantee. Internet apps, application, transport protocols. Application for email, the application layer protocol is SMTP, underlying transport protocol TCP. For remote terminal access, telnet used. For application web, HTTP used. For file transfer, FTP used. Here the underlying transport protocol is TCP. For streaming multimedia, the application layer protocol is proprietary, example real networks. For the application internet telephony, proprietary, example dial pad. Web and HTTP, first some jargon, web page that consists of objects. Objects that can be HTML file, JPEG image, Java applet, audio file. Web page that consists of base HTML file, which includes several referenced objects. Each object is addressable by a URL. Example URL www.someschool.edu is a host name. Some department /pictures.gif GIF file is a path name. HTTP overview. HTTP is a hypertext transfer protocol. Web's application layer protocol. It is a client server model. Client, browser that requests, receives, displays web objects. Server, web server sends objects in response to request. HTTP 1.0, RFC 1945, HTTP 1.1, RFC 2068. PC running Explorer, server running Apache web server, Mac running Navigator. The HTTP request and HTTP response between the Mac running Navigator and the server running Apache web server, and the PC running Explorer, server running Apache web server between the HTTP request and responses. HTTP overview continued. Uses TCP. Client indicates TCP connection. It creates socket to server port 80. Server accepts TCP connection from client. HTTP messages, application layer protocol messages that is exchanged between browser, that is HTTP client, and the web server, HTTP server. TCP connection closed. HTTP is stateless, the server that maintains no information about past client request. Protocols that maintain state or complex. Past history state that must be maintained. If server or client crashes, there are views of the state that may be inconsistent that must be reconciled. HTTP connectionless, non-persistent HTTP. At most one object is sent over a TCP connection. HTTP 1.0 that uses non-persistent HTTP. Persistent HTTP, multiple objects that can be sent over a single TCP connection between client and server. HTTP 1.1 that uses persistent connectionless in default mode. Non-persistent HTTP. Suppose user enters URL www.someschool.edu, some department/home.index that contains text reference to 10 JPEG images. 1A, HTTP client indicates a TCP connection to HTTP server, that is process at www.someschool.edu on port 80. 1B, HTTP server at host www.someschool.edu waiting for TCP connection at port 80 accepts connection notifying client. HTTP client that sent a HTTP request message that containing URL into TCP connection socket. Message indicating that client wants object some department/home.indexed. HTTP server receives a request message that forms response message that containing a requested object and sends message into its socket. Non-persistent HTTP continuation. Step 4. HTTP server closes TCP connection. Step 5. HTTP client receives responses messages that containing HTML file, displaying HTML, parsing HTML file, finds 10 reference JPEG objects. Step 6. Steps 1 to 5 repeated for each of 10 JPEG objects. Response time modeling. Defining of RTT. Time to send a small packet to travel from client to server and back. Response time. 1 RTT to indicate TCP connection and 1 RTT for HTTP request and first few bytes of HTTP response to return. File transmission time. Total is equal to 2 RTT plus transmit time. Persistent HTTP. Non-persistent HTTP issues. It requires 2 RTTs per object. OS must work and allocate host resource for each TCP connection, but browsers often open parallel TCP connection to fetch referenced objects. Persistent HTTP. Server leaves connection open after sending responses. Subsequent HTTP messages between same client, same server and sent over connection. Persistent without pipelining. Client issues a new request only when previous responses that has been received. 1 RTT for each referenced object. Persistent with pipelining. Default in HTTP 1.1. Client sends request as soon as encounters a reference object as little as 1 RTT for all the referenced objects. HTTP request message. 2 types of HTTP messages. Request, response. HTTP request message. ASCII, it is a human readable format. GET, it's a request line. GET, post, head commands. Some here, page.html, HTTP 1.1. And these are the header lines. Host, user agent, connection, accept language. And extra carriage return, comma line field. Carriage return in line field indicates end of messages. HTTP request message general format. Method, SP, URL, space, version, CR if it is a request line. And header field name, colon, value CR if to the header field name, value CR if. It is the header lines, CR if and then entity body. Uploading form input. Post method. Web page often includes form input. Input is uploaded to server in entity body. URL method. It uses get method. Input is uploaded in URL field of request line. Method types. HTTP 1.0. Get, post, head. Ask a server to leave requested object out of responses. HTTP/1.1. Get, post, head. Put, uploads file in entity body to path specified in URL field. Delete, deletes file specified in the URL field. HTTP response message. HTTP/1.1 200 OK. Status line, protocol, status code, status phase. Header lines, connection close, it mentioned by date, server, Apache server, last modified, the date was mentioned, content length is 6821, content type is text or HTML, and data, the data is a requested HTML file. HTTP response status codes. In first line in server, client response message. A few sample codes, 200 OK. Request succeeded. Requested object later in this message. 301 moved permanently. Requested object moved. New location specified later in this message. Location. 400 bad request. Request message not understood by server. 404 not found. Requested document not found on this server. 505 HTTP version not supported. User server state cookies. Many major websites use cookies. 4 components. Cookie header line in the HTTP response message. Cookie header line in HTTP request message. cookie file kept on your host that managed by user's browser, backend database at website. Example, Susan access internet always from same PC. She visits the specific e-commerce site for first time. When initial HTTP request arrives at site creates a unique ID and creates an entity in backend database for ID. Cookies keeping in state client server, between the client and server. In client cookie file eBay 8734, unusual HTTP request message, usual HTTP request message, usual HTTP response plus set cookie 1678. Server creates ID 1678 for user, and next cookie file is Amazon 1678 eBay 8734. Usual HTTP request message cookie 1678. Cookie specification, usual HTTP response message. 1 week later cookie file Amazon 1678 eBay 8734. Usual HTTP request message cookie 1678. Usual HTTP response message cookie specification, which is accessed by the database, and the all entries that is backend with the database what we are used in the system. Cookies. What cookies can bring? Authorization, shopping carts, recommendations, user session state, what email, that is web email. Cookies and privacy. Cookies permit sites to learn a lot about you. You may supply a name and email to sites. Search engines use redirection and cookies to learn yet more. Advertising companies obtain information across the different sites. Web caches, that is a proxy server. It's a centralized server from the client to the server. Proxy service act as a central one. HTTP request and response, which is received and sent to the HTTP proxy server. Goal, it satisfies the client request without involving original server. User sets browser web access via cache. Browser sends all HTTP requests to cache. Object in cache returns object, else cache request object from origin server, then returns object to the client. More about web caching. Cache acts as both client and server. Typically cache is installed by ISP, university, company, residential IP. Why web caching? Reduce response time for client request, reduce traffic on an institution access link. Internet dense with caches enables poor content provider to effectively deliver content, but so does peer-to-peer file sharing. Caching example, assumptions. Average object size is equal to 1 lakh bits. Average request rate from institution's browser to original servers is equal to 15 per second. Delay from institutional router to any original server to back to router is equal to 2 seconds. Consequences, utilization on LAN is equal to 15%. Utilization on access link is equal to 100%. Total delay is equal to internet delay plus access delay plus LAN delay is equal to 2 seconds plus minutes plus milliseconds. It is an institutional cache. Caching example continuation. Possible solutions, it increase bandwidth of access link to say 10 megabits per second. Consequences are utilization on LAN is equal to 15%. Utilization on access link is equal to 15%. Total delay is equal to internet delay plus access delay plus LAN delay is equal to 2 seconds plus milliseconds plus milliseconds. It often a costly upgrade. Caching example continuation. Install cache. Suppose hit rate is 0.7. What are the consequences that we are facing is 40% of request that will be satisfied almost immediately. 60% request satisfied by origin server. Utilization of access link that is reduced to 60%, resulting in negligible delays. It says 10 milliseconds. Total average delay is equal to internet delay plus access delay plus LAN delay, which is equal to 6 into 2.01 seconds plus milliseconds, which are less than the 1.4 seconds. And conditional get. Goal, don't send object if cache has up-to-date cached version. Cache, it specifies the date of cached copy in HTTP request. If modify since from the date to the date. Server, responses that contains no object if cached copy is up to dated. HTTP/1.0 304 that is not modified. This is the object modified, and the above figure is given is object not modified. FTP, the file transfer protocol from the user at host, FTP user interface, FTP client that are located in the local file system. FTP server, it is a remote file system. The file transfer between the FTP client to the FTP server. FTP, separate control data connections. FTP client contacts FTP server at port 21 that specifying the TCP as transfer protocol. Client obtains authorization over control connection. Client browses remote directory by sending commands over control connection. When server receives a command for a file transfer, the server opens a TCP data connection to the client. After transferring one file, server closes connection. FTP client and FTP server, TCP control connection port 21, TCP data connection port 20. Server opens a second TCP data connection to transfer another file. Control connection out of band. FTP server maintains state, current directory, earlier authentication. FTP commands responses. Sample commands. Send as ASCII text over control channel, user username, password. List written, list of file in current directory. RETR, a file name. Retrieves gets file. Store file name, stores. Puts file onto remote host. Sample written codes. States the code and phrases as in HTTP. 331 username OK. Password is required. 125 data connection is already open. Transfer starting. 425 can't open data connection. 452 error writing file. Electronic mail. 3 major components. It mentioned the outgoing message queues, user mailbox. 3 major components: user agents, mail servers, simple mail transfer protocol, that is nothing but SMTP. User agent, aka mail reader, composing, editing, reading mail messages. Example: Euroda, Outlook, LM, Netscape, Messenger. Outgoing, incoming messages that is stored on the server. Electronic mail servers. Mailbox contain incoming messages for user. Message queue of outgoing that to be sent mail messages. SMTP protocol between mail servers to send email messages. Client sending mail server, receiving mail server. Electronic mail, SMTP, it uses TCP to reliably transfer email messages from client to server. Port 25, direct transfer, sending server to receiving server. 3 phases of transfer: handshaking, greeting, transfer of messages, closure. Command/response interaction. Commands ASCII text, response status code and phrase. Messages that must be in 7-bit ASCII. Scenario: Alice sends messages to Bob. Alice uses a UA to compose messages and to Bob at someschool.edu. Alice UA send message to her mail server. Message placed in message queue. Client side of SMTP opens TCP connection with Bob's mail server. SMTP client sends Alice's message over the TCP connection. Bob's mail server places the messages in Bob's mailbox. Bob invokes his user agent to read messages. Finally, sample SMTP interaction. S220. Sample SMTP interaction S220. இவ்வளோ தூரம் பேசி கடைசி நேரத்தில் கால் பண்ணுறாங்க.